Hey everybody, happy Monday. Just checking that everything's working. What does everyone think about the new Twitter feature of fleets? I can't even believe they came up with that name. They should have just called it what it is, stories, which has now apparently just every app has them. I just tried my first one today. I'm not going to lie, it's a slippery slope for me. I like to talk. I used to share a lot on Instagram stories, so maybe Twitter will be the new place. Although the camera is a bit funky. It doesn't seem to record great quality. Right, let's bring in the man that you're all here to see. Cedric.
Hello, good evening.
Good evening, how are you?
All good.
Good. Happy Monday to be back talking all about Azure Serverless.
Exactly. Today will be a lot less PowerPoint and a lot more code.
Exciting. Okay, everyone. So everyone who's watching, get prepared to code along with Cedric. But before we do that, if we could scan the QR code that you see on your screen right now, or go to the link that you see on your screen, I will copy that into the comments for you, so it's easy. This will give you access to free resources from Microsoft relevant to this session, and it's also really great feedback for the Cloud Lunch and Learn team because Microsoft sponsors us, so it lets them know that people are attending and engaging with our sessions. So we would really appreciate it if you'd register for the session. If you're viewing now or you view it later, register and get those resources. And I'm just going to get the link for them as well. Okay, so today we're going to cover functions, which is exciting. I'm just going to make sure that I give you guys this link in the chat before I disappear, or I might not do it. I might forget. That's kind of how I'm feeling this Monday. Everything's a bit have to do it.
Mondays tend to be a bit difficult, right? We gotta get started.
Yes, I've been on call since, so it's 6 p.m. here for us in the UK. I've been on a call since 4 p.m. and I've got a call after this as well. But this and my next call are fun and exciting things, so that's not too bad. Hey, Jarez. Okay, guys, right. I will post this link in the chat, but we should probably get started with the session. So, Cedric, I will leave it to you. Have a great time.
Thank you very much, Lisa. Thanks. All right. Cool. So, good day, everyone. I'm Cedric. I'm going to do the follow-up on last week's session. Last week, briefly recap, last week we talked about serverless technology on the Azure platform, from functions, logic apps, and some Azure container instances. I think were the three main compute instances or compute options we discussed. Today we're zooming in on Azure Functions, and the goal really today is to deploy a couple functions, right? Do some interesting stuff with functions. And generally speaking, get a feel for how development of a function would look and how that differs from developing your classic applications, your classic maybe integrations or APIs, right? Today we will be using, for the first sample, we will be using Visual Studio. I will be running Visual Studio 2019. You could do the same with 2017. If you don't have that installed yet, then maybe sit this one out and maybe redo the exercise afterwards at your own pace. The second application, we will be developing an API, small API for doing some to-do maintenance, let's say, and that we will do in Visual Studio Code, right? So if you have one of the two, in theory, the second one you can also do in Visual Studio, but it will just be slightly different from what I'll be doing on screen. So let's dive in. The first one I want to show here real quick is a slide briefly recapping, right? We talked about functions a lot last presentation, and we we talked about the fact that it's event driven, that it's stateless, short-lived, single responsibility. We want to do quick things with APIs. We want to do we want to go ahead and develop fast. So making sure that it's just simple, small, short-lived, trigger-based pieces of code. That's what our ultimate dream is. And for that, we went into Visual Studio here, where we created our first application. Right? Remember Hello World, where we did some cool stuff. And I mean, just a very simple application. We will continue on that today, but first, again, I just want to make sure we set the scene. If people didn't see the first session, very briefly recap, because we don't have super much time in an hour. We want to do a lot. What are functions, right? Event-driven. You have a trigger. You run some code in any of your preferred languages, which we discussed as well in the last session, and you have outputs. And that's what mainly we will be playing with today. Now, before doing our first demo / exercise, there is some additional concepts we want to discuss. One of them being application settings. An application setting in a function is a bit like an environment variable, if you wish, right? You have your global environment variables on application level, which you can set. For example, here you see an app insight instrumentation key, where I integrate my function with my application insights, which we'll see in a minute as well, how that relates. There's some function-related global variables, but I can add my own application settings here. So if I want to connect with a SQL Server or Cosmos DB, or if I need an API key or some sort of secret value, I can add an application setting here and configure that from here. Again, this is fully accessible through code, so you don't have to do it always through the portal. But today, because of the limited time we have, we'll mainly be managing this through the portal. Note that in all our documentations, or in all the Microsoft documentations, there are references to the command line as well. And in some of the samples that I use today, or that the exercise today are based on, you will find those commands as well to do that from a code perspective, if you want to integrate that with your CI/CD toolkit. So application settings, quite important, accessible to your function. One pretty cool or neat thing here is, as you know from last session, hopefully you remember that we briefly talked about, there's this thing called deployment slots, where you can have a function running in your production slot and then deploy your next version to staging and then swap these. Now, often what you will want to do is, especially if you want to use something like UAT or test as a slot, you might want to have different databases where your versions are communicating to, or maybe different storage accounts for logs and so on. So you have slot-specific settings, and that is just a checkbox where you can say, okay, I want to have slot-specific settings for this slot, and I want to configure value this storage URL for testing and this storage URL for production. Now, when looking at the second thing we want to see today, that is auto-scaling. Now, auto-scaling in functions in this first exercise, I think is a very nice example of auto-scaling. Auto-scaling itself is is native to the consumption-based and the premium plans. We're not going to talk about the isolated plans because that is kind of dedicated compute. That is not as serverless as we would want functions to be, I guess, right? That is again paying for compute instances that are fixed. In the consumption and premium plans, you do have this auto-scaling concept out of the box, where it is kind of always on, and depending on the type you're using, it kind of differs how it scales, but it's more or less the same, but not in full. So how scaling works is depending on the number of incoming events. So if, for example, here, if we use a storage queue or a service bus, depending on the number of events, the number of triggers, and essentially, that's what decides how fast or how slow your application will scale. Now, in premium, it works kind of like the same, but it has the added advantage that you have something called a warm instance, or a configuration options for warm instances. That means that on the consumption-based model, and we'll see that in a second when we do run through the exercise, you have the concept of a cold start. Now, that means that when you first deploy your function fresh out of the box, it can take a couple seconds before it's really up and running, right? Your first API call might take a little bit of time, a couple seconds, noticeable, but there will be a delay on that first run, which might be sometimes a bit annoying for production workloads. That's why in the premium plan, you can configure that there is an always running instance of your server. Now, talking about servers, the instance size of your function instances is for the consumption-based plan, 1.5 GB of memory max and a single CPU. In premium plans, kind of decides on what SKU you put underneath those, depend on the underneath those instances. One important thing, scaling by default, it's going to scale as much as it can. Right, there are some hard limits, but you can find those in the docs as well. Most people will not get there, especially today. I don't have enough source material to fire at the function at once anyway to simulate that bottleneck. But there is also this concept of limiting your scaling. Right, it's quite important because your function, as it grows with the demand, whatever is behind that might not be able to grow as well. And imagine you're having a SQL server where you can't scale potentially as flexibly as in your function, right? You're limited to the amount of CPUs you've provisioned there. You don't want your functions to scale out more, where your SQL Server will become a bottleneck. So you want to keep that a little bit in line, and that's something you can do with that scaling limit. So that's quite important that you can control a little bit your scale controller in as how much you will allow him or the component to scale. So that is, I think, the first 10 minutes, setting the scene, briefly talking about these two concepts, and we're going to dive in directly into a short exercise/demo. So what we're going to do here is the image resizing tool. Now, it is part of a tutorial in the Azure Event Grid documentation where we're resizing applications, or we're resizing images. And before that, there is a step where you can deploy a web app and then upload your own images. We're going to kind of skip that because that's not what we focus on today. We focus today on our Azure Functions. So we're going to mainly do that part, and there is quite some clicking together of resources that we're going to do. I'll go through them here in the video. Might be a bit too fast. If it's too fast, again, try maybe if you want to do the full demo, rewatch this session maybe and do it at your own pace, so you can pause, or you can even pause in the live version if you wish, but feel free to pause maybe briefly to catch up if it goes a bit too fast, just to make sure you can go ahead. We're gonna try and keep some nice flow in here. So let me get my browser here with the Azure portal. So I have my resource groups here. Let me get my notes real quick. And first thing we need to do, of course, is we need to make sure we have our code of this project. Right? We're gonna not write all the code ourselves, and we have this code here in the Azure Samples repository. So at Azure Samples, we have a function image upload resize, which offers us a small piece of code where we got an image function with some C#, where we will have this thumbnail function, which is quite a elaborate code on resizing your JPEG images. Now, because writing this real time would be a bit of a stretch, we're just going to reuse this beautiful code here. So I'm going to copy the Git link, open a command prompt, go to my code repository here. Let me share what I'm doing. So I'm in code. I have a Cloud Lunch and Learn folder with the serverless one, and there I'm going to go in my live folder and create here and do a git clone of that repository in here. So that's going to pull in the resources. If we look here, we're going to have a function image upload resize, and we have this solution in here. Now, when we open our browser here, our Explorer, we can go in there and open in Visual Studio. So while that opens, let me share my Visual Studio here with you. Once it's opened the project, right? Right, here we are. So this is Visual Studio. We can open here our C# function, and again see that code where we resize the function. Now here I'm going to close some of these functions here that are less relevant. We're going to go down to the actual function itself, which is here. This is the entry point of your function, your task run. And what we see here is we have an event grid trigger. So we're going to use an event grid to trigger this function. Now that means that we're going to capture somewhere an Azure event, in this case, a storage event. We're going to then trigger an event grid, which this function is subscribed on. And as an input binding, or an output binding, I should say, we have a blob storage where we're going to read and write the files to. So it's a binding to that blob storage here that we have on line 76. Let me scroll and zoom in a little bit. One quick important thing, if you want to deploy from Visual Studio, here you need to rename this file here, because you need a local.settings for Visual Studio to understand that we're talking about an Azure function here. And from here you would be able to deploy, but of course we first need some resources in the Azure portal. So let's go ahead here and go to our Azure portal and create a fresh resource group. I'm prefixing everything I do here for Cloud Launch and learn with CLL just to make sure I keep it nice and together. I'm going to create this my image resize live. I'm going to deploy everything here in Dublin in the North European Data Center and just have that created for me. Now within this, right, we're going to resize images we upload, right? That's the function we're going to call. Now to do that, we need a place to store the images or to provision the images and a place to store the output. To do that, we need a storage account. So when I go here in our image resize live, I'm going to add a resource and we're going to add a storage account. A storage account, right? So I'm going to create this one here. We're going to create that in image resize live. We're going to call this something unique image resize live. I'm going to call it 2 just to make sure it doesn't overlap with what we made earlier. And we're going to as well deploy that in North Europe. One quick don't be too fast here. Change your replication to locally redundant. Since this is a demo, we don't need a geo-redundant storage. We can deal with local redundant. I mean, that is still 3 copies within the same data center. That is more than enough for redundancy for our solution here. We don't need to replicate between North and West Europe this data. The rest of it, of the storage configuration, you can leave standard. Just create one here, and we can go ahead. Once that storage account is created, we're going to create 2 containers. One called source images and the second one called thumbnails. Both of these containers we will allow public access to, just to make everything a bit easier. When you do create these things in for production use, please use the relevant permissioning for your storage accounts, right? Don't leave or don't set them to public accessible. So the first one here we said was source images. Source images, everything lowercase, no spaces, of course, and the public access level, we're gonna have that on anonymous read access. So we have to deal a little bit less with our identity later on, making this demo move a bit faster. In a production environment, you would probably create a managed identity for your function and then grant that identity access to the relevant storage blobs. In our case, we're gonna use just the public access key and leverage that. Our second container we said was going to be thumbnails. So I got that handy here. Again, public container access. And those are the 2 folders we need. So that's our storage. The next step in this deployment is we need to create our function where we will want to deploy to. So why we're doing this is I just want to show you a couple of different ways in how you can develop with functions, right? There is not a single correct or the only way to do it. There is always multiple ways to do certain things within Azure. We're going through the portal mainly today. All of this you can do through CLI, through templates, through ARM templates, through Terraform if you wish. We're going to make here an image resize live. Should still be available. We're going to use .NET Core. We're going to deploy this in North Europe. We're going to go quickly to the next tab here, just to verify. We're going to use the storage account where we will store our code. So Azure Functions needs a place to store some diagnostics and code. We're going to keep it in consumption-based plan. And let me just make sure everything's large enough. In the monitoring tab, we are going to enable application insights, because this in this demo, what we're going to use here is the live diagnostics, so we can see real time what's happening with the function. So once you've created this or set this up, you can go ahead and create. And this will take a couple seconds, maybe a minute, to create your function and set up everything nicely. Now, one thing while this deploys, one thing we need to do is when we go to our Cloud Lunch and Learn here image resize demo, we need to copy the access key of our storage account. So when you show these account keys here, we're going to copy this one because we need this in our for granting access to our function, right? So in the meantime, let's have a look how that's going. So we have our app service plans here, app insights workspaces here. We're still missing a storage account for our function to store some of the diagnostics and code, and the function app itself, right? So let's see if that wants to deploy fast today. And so from here on, what we're going to do before we can deploy the code, I mean, essentially we could deploy the code the moment our function has been deployed here. We can deploy from Visual Studio Code. But what we want to do here first, now that we're in the portal anyway, is configure some of those application configuration settings, right? We need to make sure that our function can access the storage we've provisioned, right? The thumbnails and the source images, right? Because it needs the source images to convert them into thumbnails. And we need to add some basic configuration parameters that our source code needs. So if you look here in the source code while that deploys, let's have a look here at thumbnails, and we'll see that the first one that is red here is the environment variable Azure Web Job Storage. So that's the storage account that will be used for reading the thumbnails or the source images and writing the thumbnails. Another quite important variable that is being called here is the thumbnail width. So we're gonna set a fixed value there of 100 pixels to make the width, and the output container name. So these are the three main variables we need to make sure are properly configured. Let's have a look. The deployment has finished, it appears. Deployment succeeded, so let's have a look there. So here we have our function app that has been deployed, and like I said, we're going to configure those application variables. Now that is found here underneath the settings configuration, where you have these application settings. So first, what we're going to do is we're going to reconfigure this Azure Web Storage account. We're going to set the storage account we had earlier, what we copied from our earlier setup. So I know this is a bit redundant. We probably should have done during the deployment, change that from the start. But let's use our new storage, just because we already did that and everything is nice there, or everything is provisioned there. The next one we need to do is our thumbnail container name, excuse me, which has an underscore. And let me make sure I don't copy some of the format here, because that's we don't need. So thumbnail container name, all caps, right? Thumbnail container name with underscores, which is going to be thumbnails, right? That's the folder we created. And the last application setting is thumbnail width with an underscore, and that we're going to set to 100. So here, that's that deployment slot setting where you could add this as an optional to a specific slot. Now, when we save this, these settings will be applied, and we can continue with our actual deployment of the function. So that brings us back to Visual Studio Code. Visual Studio Code is definitely an easy IDE to post functions from, and by far not the only one. Visual Studio VS Code is, of course, another. There is also Eclipse, for example, if you develop in Java, and there's most IDEs today have some sort of support for Azure Functions. Now, to publish the application, right, we right-click on image functions, go to publish, select our target to be Azure, and here this should say function instance. If this says container instance, that probably means you have not changed your local.settings.json. So make sure you've changed the local.settings.example.json to local.settings.json to make sure you Visual Studio understands that this is about a function project. So let me sign in here to my account. We're going to use my current account. We're going to select your subscription, the relevant resource group, and then it's going to search for a bunch of functions. So we have here our live demo CLL image resize, and then our function itself, which we can choose as our destination to publish our application to. Now from here, we still need to click publish. And at this point on, the code will be pushed to your function and stored in that storage account, right, for use from within your function. So this can take, again, a couple of seconds. That's why we already generate the function and all. So that's all ready, and you just need to publish. So that is almost finished. And once that is finished, we can have a look what happened there, because we still miss one last item, right? In the code here, although we say, hey, we're going to have an event grid trigger when there's an event, it doesn't specify anywhere which event grid subscription or topic you're subscribing to. So that is one thing you will have to do in this case, at least, again, through the portal. Again, like I said, in the next demo or exercise, we're going to generate much more from a code perspective, or configure much more from a code perspective. For this one, you will have to go through the portal. So when we look here in our function itself, in the functions tab, there should be appearing a function thumbnails, which sometimes it takes a little bit. So let me just refresh here. Let's go to CLL, the live demo, right? We go to our image resize, and then by this time, hopefully it has appeared. There we go. When you click through, I think something we saw last time, you have the integration tab here, where you'll see, okay, it's based on an event trigger, and then it's going to call this thumbnail function. Now, this event grid trigger we can configure from the portal from here. So from here, we could just say create event grid subscription, and here we're going to say, let's call it Cloud Lunch and Learn image resize live, and this is the sub. It's going to be an event grid schema, and very important here, what is the topic we're going to listen to or we're going to subscribe to? Let's say that is a storage account, right? Storage account where we will store the images. We're going to select our subscription. We're going to select the CLL live environment, image resize live, and the resource within that will populate automatically. That is our storage account here that we'll want to subscribe to. We need to give that topic a name. So again, CLL image resize topic. And very important here is what type of events do we want to subscribe to? In our case, since we just want to resize an image the moment it's added, we want to generate that thumbnail, right, for our website, or maybe you just want to use this to maybe resize automatically new wallpapers you've downloaded to the size of your desktop instead of having them in all kinds of different sizes. So we only want creation events. We're not interested in delete events. So that's quite important. Make sure you create this. Second thing you need to do, quite important as well, is at this point in time, as you've configured this event grid subscription, it's subscribed to all your events within your container, right? We're not saying anywhere, hey, we only want events from our source images folder. If at this point in time, any file we add anywhere in the blob will trigger this, or will come into the subscription and will in time trigger our function, which would also mean that a thumbnail would trigger the function again. Kind of a infinite loop scenario you see here, so probably not what we want. So we do need to configure a filter here. So on top, basic filters. If you've already finished this and you want to reconfigure them, I'll show in a second where you can do that. But essentially, there's a filter tab on your event grid subscription. So here, what do we want to filter for? That is the blob service default container, and then the name of your container blobs. So we only want blobs within the source images container. We also only want to subscribe to JPEG files. All right, quite important, this one. If you forgot or if you don't know the path here, one fairly simple way of checking is create a quick file here. Make sure your function is stopped or disconnected. Create a file here and have a look at the event itself that was generated. So we can create that one here. At this point in time, right, we create a storage account, create a subscription on the create events within that storage account, within the source image folder, let's say, or container. And we've added that subscription to our function. So when we create an image here in this folder, once this is finished, we should be able to trigger our function. Now, how do we see that easiest? Well, there's a couple of ways. I'm going to switch tabs here. We're going to go back to resource groups. We're going to filter for Cloud Launch and Learn, our Resize live environment while it deploys. So there's a couple of ways of viewing what's happening within your function. First one is just going through your function, having a look here at your home page, but there is somewhat of a delay on this. This is not 100% real time, so you might see triggers or functions being triggered with a little bit of delay. Same if you just go to your monitoring here, when we go to metrics or log streams, there might be a bit of a delay there. So what we want to see is our live data. That is something cool that Application Insights introduces. So if you click on your App Insights workspace, you have this thing called live metrics here. Now, if we go to live metrics, we will see if our function is running, how many instances there are, and how many calls we're having, even some of the telemetry. So at this point in time, we see there's one server online. And if I scroll down here a little bit, we even see that the server here is getting 0 requests, not doing anything much, barely using any CPU, any memory, right? So it's essentially not doing anything. There's nothing arriving here. When we switch back here, we can close our trigger. We can go back to our resource group and we can start and upload our first file. So let's have a look here in our containers. We go to source images, we say upload. Let's browse here. And if all's good, I have here a bunch of wallpapers from our good friends at Unsplash, who offer some beautiful resources. And the name of the person that took this picture is, of course, in here. And what we see here is in our live metrics, wow, there's one event coming in. The delay here, the duration was less than 3 seconds. We see a couple dependency calls. We see a short spike in CPU, and we essentially see the thumbnail was processed and published. If we go back through our storage account, let's have a look at thumbnails. We have this nice thumbnail, 3 kilobytes. That's pretty nice. Now, it's all cool that we can do that with one image. The thing with functions is that it scales, right? That is what we expect. We wanted to be able to handle large amounts of data. So let's see if we can push this function a little bit. And let me delete this one here. And let's add all of the entire library here that I have in wallpapers. So these are fairly large files, right? These are wallpapers, fairly big, 2 megabytes up in size, right? 2.13, this one 1.9, this one 1.5. I think I have about 50 or 60 images in here. So the moment I upload these in here, we're going to trigger our function, and our function is going to realize, like, hey, there's 50 triggers here or 50 events. I can't handle this by myself. I'm going to spin up some additional nodes. So let's give this a go. And what we'll see here in our live metric is that as events come in and as these metrics update, right, we see that the function, the delay, shortly starts spiking, and that the number of servers is going to start going up. And especially here, you see the CPU is at 80%. That means it's going to add some servers, and we have 4 by now. And the work gets divided, and our thumbnails are being generated. Right? I'm still uploading. My functions are working faster than my actual upload speed. And in my thumbnails library here, you'll see the files being added. Now let's have a look how our functions behave. if my upload goes really well, I can push it to 8 servers. If it's a bit slower, it kind of gets stuck on 4. But it's pretty cool, right? Seeing these events being triggered, seeing your dependency call duration staying fairly reasonable. We do get some failures because there's apparently a couple bad images that it can't seem to convert that I haven't figured out yet or fished out yet out of that folder. But you do see that the response time or the request rate is pretty decent. The failure rate stays low, CPU spikes briefly, but that's it. And at this point in time, all images have been processed. Everything goes back to 0%, and give it a couple seconds, couple minutes, your number of servers will again spin down to 1, and after some time even to 0 essentially when there's no load, and go into that cold standby type of method. And here now we have all our nice resized images or thumbnails in this folder. So that's the first walkthrough exercise / demo that I wanted to share with you. How easy and fast it can be to do something in bulk or event-based on doing some sort of image resize from a function. Now, of course, writing this code here seems a bit complex, right? Use a couple libraries to do this, but it is code that it's not an exaggeration, right? 121 lines. That's not a lot of code to do something as cool as or as efficiently, including scale and everything, right? I would be interested to see something similar that auto scales in 121 lines of code. I think that would be a nice challenge. That being said, our service will scale down again, and the metrics will stabilize. Now from here, again, just briefly want to share, this is the original repository I used. It is part of our resizing using event grids. So this is a tutorial here where they use a web app to upload pictures and then generate that thumbnail. If you want to do this tutorial full on, you can do it with the web app as well and walk through it step by step in your Azure portal. It's very well explained. You don't need to change any of the code. In our situation, I just adapted this slightly, this tutorial, just to focus on the functions, right? So go ahead, have a look at the event grid documentations, part of the tutorials, image resize with event grid. It's a pretty fun thing to do. Now back to our presentation here, because another thing we talked about, and what we're going to try and do in the next 30 minutes, is we're going to try and build an API for our to-do tasks. So what we discussed in the previous session was we talked about triggers and bindings. Now, we briefly glanced over this. We had a trigger, we had inputs, we had outputs, and there were several types there. It's important to know the difference between triggers, inputs, and outputs. And I remember when I started out with functions, it was a bit weird, but why isn't a trigger an input? Isn't that the same, an input and a trigger? There's a difference, right? A trigger is essentially the event that starts your function, that tells your function, hey, wake up, there's something to be done. An input is something you can add next to that trigger, right? A trigger can be an HTTP request. An input could be something that is on a blob storage, or a trigger could be, in our previous example, the trigger was the event grid that triggered the function, and then there was an input binding with the blob because we needed to get some storage or some file from a blob store and then do the processing. So that's your input binding, and we'll see that later on in the exercise when we do the to-dos. An output binding is something that we could use or add when we have somewhere with the result that we need to put. So in our case, when we create this to-do API, what we want to be able to do is offer an HTTP endpoint, an API, a REST call, where we can send a small JSON to with some to-do information that needs to be persisted in a Cosmos DB, right? That's our trigger. In this case, it's HTTP, and our output is going to be a Cosmos DB. At the end of the demo, we're going to do the other way around, more or less. We're going to have Cosmos DB being our input trigger, and our output in this case is going to be a storage queue, where we will persist our messages again to maybe trigger some additional logic. Another thing I briefly glanced over already was IDEs for development. We talked about Visual Studio Code. That's what we're going to do now. You could also do this in Visual Studio. You just need to make sure you have your Azure Functions and Web Job tools installed and enabled. So verify that, double check that before you go into Visual Studio. Visual Studio itself, if you just search when you create a new project functions, you will get the right project. It should be a C# one. And from there, we can continue. Right, so let's dive into the code again. This one is going to be a bit more coding, so it might be, again, I'm going to try and not go too fast, but I'm also going to try and stay within the time allotted for this session, making it that it might be a bit too fast if you really want to type along and code everything along. But again, feel free to pause the video, type along, or finish the command and then continue with the video. I'm going to make sure I show every single step of the process so you can replicate that when you want. The demo is based again on our Azure samples to do functions, and I'll make sure we get that in the description of this session. That we include the references. And if you want to look at the demo source code itself, you can find that on my GitHub page, Cedric Steenbeke, in the simple to do functions repository. That's a public one, so you should all be able to find that. So let's dive into it and try and make an API in less than 30 minutes, right? So we open Visual Studio Code here. I just opened an empty folder called To Do App. And the first thing we need to do to start coding is, of course, create a function, a project. So we do that here by going to the Azure logo. We don't want an app service, we want the function, and you can create a function through this one. That's what we essentially saw in our latest, in our previous session. So I'm going to use C#. It's going to be an HTTP trigger, and we're going to call this one the create to do. That's our function. I'm going to put everything under Cloud Lunch and Learn, and we're going to make the access rights anonymous. Now, this generates a bunch of files, and important here, of course, is your create-to-do.cs file, but as well as your local settings with some variables, and very important, your CS project, where you will see variables, or not variables, references, dependencies. So first things first, we have here a create to do function, which is an HTTP trigger based function, which is anonymous. Going to listen to both get and post at this point in time, but we're going to already create, change here the route, and we're going to call this to do. So our function URL will be our something dot azurewebservices.com/API/to-do. That's where we want to host this. We're going to leave this nice and easy and start immediately deploy this, so we can trigger that deployment, which might take again a couple minutes, maybe even, so that is happening behind the scenes. So we're going to go here, deploy function. We're going to deploy this to my subscription, and I know we didn't configure anything yet. That's why we're going to go the advanced route. So here we're going to add a globally unique name for our function. So this is Cloud Lunch and Learn to do demo. This is going to be live. Our runtime stack is .NET Core. It's going to be Windows-based, consumption-based, of course. And we're going to create here a new resource group, which again, I'm going to follow by naming to do live. That's where we're going to name. Create a new storage account. I'm going to add store to the back. New application insights. We're going to go app insight. We're going to deploy it in North Europe, of course, and get that started. This triggers a whole process. I think is going to deploy about 5 resources. Going to deploy our resource group, storage account, where we will store our function code, a function app itself, the app service plan, the application insights. That's the resources it's going to deploy from here. Okay, so we now have a function that is going to do basic HTTP, which we can probably, if we, once it's deployed from Postman, we can just test or just serve to, and we'll get a probably this executed successfully pass a name. This is of course not what we want, right? We want to be able to post messages, that's one, to this function, and post them with a certain body of a JSON. Right now, the first thing we need to do is make sure this function only listens to post requests. We don't want to process GET requests. We want to be only able to push data there. Let me double check that we're on track. So we are deploying this. So we're deploying this freshly. That's all good. Next thing we need to do is, so we're going to only allow post. In our next deployment, we'll do that. We now want to make sure we add a Cosmos DB binding. Now, to add a Cosmos DB binding, we of course need a Cosmos DB. So let us go here to the portal. There should be by now a fresh resource group here, our to-do live demo, and we're going to add here a Cosmos DB resource, again manually real quick, so we can access that. So same subscription, Cosmos CLL to-do live. We're going to call this CLL Cosmos DB live. I'm going to keep it with core SQL. I'm going to keep the preview features off. We need a fairly simple standard one. I'm not applying the free tier discount. Do please do that in your subscriptions. In my subscription, it's not enabled, so I can't use it. But do please use it because we can do everything within the free tier. Go ahead and create that, review it, create it, and let that run as well. Now, one thing we need from our Cosmos DB is a bit like the storage account, right? We need that URL where we can connect to the Cosmos DB. So we will need to copy that access key again once it's deployed, so we can connect our function to it and have it deployed to this environment. While this deploys, let's not waste too much time, and let me add some code here to be able to connect with Cosmos DB. And of course, I have the code here next to me in a separate window, so I can easily copy paste. And let me share that right here. So I can just add an additional binding for Cosmos DB, where I say, okay, Cosmos DB binding, my database name is going to be to-do items. I'm going to have a collection items in there, and my connection string settings, the key that we will copy paste soon, is going to be called Cosmos DB connection. Now, this one here, really important, is a reference to an environment variable, right? Even if it's just a string, this is going to search for an environment, a variable called Cosmos DB connection, and get the data from there. The output of this is going to be a collection of to-do items, which is a class we will need to create, and just give that a name, to-do item. Now, for this to work, for this code to work, we do need to do some additional things. So I opened here very niftily already the page called Azure Cosmos DB output bindings, which is part of our functions documentation underneath the reference triggers and bindings Azure Cosmos DB. And one important thing here is to create that output binding. You can have a look here in the documentation. Essentially, it has the code for you already here, right? So it says Cosmos DB trigger write one document. Now we're going to use the iAsync collector. So this is the piece of code that I copied from here, essentially, right? And what we're going to use. Now, to be able to do that, really important is to have a look at that overview page. In the overview page, it tells you like, hey, if you're using functions 2 and higher, you need to make sure you have those dependencies. And in this case, we need this NuGet package or NuGet package, the Microsoft Azure Web Jobs extension Cosmos DB. So it's always important when you go have a look at bindings and you want to integrate with other services, double check that overview page, make sure you have the dependencies that are necessary, part of your project. So when we go here to the terminal again, terminal, I can just paste that .NET add package, and it's going to add for me in our CS project file that dependency on Cosmos DB. If you don't do this, you will not be able to build or publish your code here, right? It's going to give a bunch of errors on your Cosmos DB thing here. All right, cool. So that means we can now accept HTTP triggers on post on the to-do path. We have a connection if we give this connection variable something sensible with Cosmos DB, but now we need to do something with that, right? And this is not the code we are looking for, so let's remove that. What we want to do is, first of all, we're gonna and this is something you can see here, right? It adds the stream reader to get the body, the request body. This is something we're going to build off. So we're first going to get the request body and convert that to JSON, right? So we get the request body and we're going to deserialize that to JSON. We assume that's going to work because we're going to publish JSON. From there, we're going to do some validation, right? We need, or we want at least some a title as part of our JSON, of our data here. So we're going to verify, is there a to-do title part of this? I added this piece of code to make it feel a bit more quote unquote real, because normally you would do some validation right on the input data, make sure that it's JSON, make sure that it has the fields you expect, and make sure everything's there that that you expect to be there. And then last but not least, we're going to insert this into our Cosmos DB. So if there's a title, we're going to generate a new GUID, create a to-do object, which I'm going to show you in a second how we do that, and then give it these parameters, making sure that it's not completed, has a due date, has a user, and so on. And this is where essentially the magic is happening. We're going to call our to-do item out, right? Remember from binding on line 18, and say, okay, add asynchronously this to-do item to Cosmos DB. And once that's done, we're going to return an OK result, an OK object result, saying like, hey, everything went awesome. Here's the GUID. So if you in your program want to do something with that ID, maybe you fetch it immediately, you could do that here, or generate, give back a JSON body, for example. So very important, we need to generate that to-do class. So we're going to make a new folder. We're going to call it models. And in models, we're going to create a new file called to-do model.cs. And in here, fairly easy or simple model, we're going to create this one here, right? CLL models, which we're going to have to import with an ID, a title, description, user, due, and so on. Getter, setters, super simple, nothing super special here. The only thing we need to do is, sorry, we have to add the import here using models. So that in a way should do the trick already. If we deploy this function and we make sure this Cosmos DB connection string is present, this code alone should be able to get a HTTP request and persist whatever we put in that JSON body, as long as it has a to-do title, into our Cosmos DB. So let us save that here and let's try and publish that. All right, so we go back to our Azure icon here, press the publish button. We're going to deploy within this subscription. We're going to deploy to our where is my to-do demo live function, and we're going to override whatever was previously there. Now, maybe in the next session we can have a look how deployment of functions could look like if we do this from a Azure DevOps or GitHub Actions point of view. But again, like trying to keep sessions like this within the hour sometimes stretches a bit the possibilities. But if there's interest, do feel free to reach out to the Cloud Lunch and Learn team if you want to see how that would work from a GitHub or an Azure DevOps perspective, and we might be able to plan some additional settings early 2021 to see if we can include some GitHub Actions and Azure DevOps, maybe even do a partnership with DevOps team here on Cloud Lunch and Learn. So while that deploys, that being said, right, while this deploys, let's go hunt for that Cosmos DB connection. So I'm going to copy this already and put this in my notepad here on the side. And let's go to the portal here. So when we're here on our Cosmos DB, let's have a look here in our Cloud Lunch and Learn resource group where we do the to-do live demo. There's a Cosmos DB. And in the Data Explorer, we can create our database and a new container. So our database we set here in the code, we were going to call, let me double check, we're going to call to-do items, capital T, capital D, capital I, and we're going to for now keep this manual. I'm going to put it on 800 just to make sure we don't get a bottleneck. 400 should do, especially when you're using the free tier. Just keep it at 400, should not be any issue. This creates our database. Once that's created, we needed to create that collection, right? Remember our items collection. There won't be anything underneath here. So we create a new container. in to-do items, going to be called items. For now, partition key, I use the ID field. You probably, again, production might want to reconsider that and choose a better partition key, but that will be for a Cosmos DB session. We might zoom in on partition keys for Cosmos DB. So from here, we just provision that collection or that container. So we can write to that. And then the last thing we need to do here is go to our keys on the left here and copy that primary connection string, right? As always, normally don't show your private keys on YouTube. Not a good practice. This could end up badly, but I will clean up my environment after the demo, so no worries there. But please don't share these type of values normally on a public forum, right? Also, again, because of lack of time, I'm gonna put this one directly in my configuration here. Normally, what you would do is generate a managed identity for your function and integrate with Key Vault to store that secure value. So we publish that here, and then from my notepad here, I'm going to add the Cosmos DB connection. All right, that's it. Once that's saved, we should have a function that is deployed, that is able to connect to our Cosmos DB and persist these values. Now let's take Postman with us here. This is Postman. This is from my earlier test. So let's get the function endpoint and put that in Postman so we can have a test and see if this actually works. Let's get the function URL here. Postman, and we replace this part, this entire URL actually. There we go. Now I'm going to start with our first to do, not this one. Our first to do here should be done by the 26th. And if we send this and everything went well, we should get a status 200 and the newly generated unique identifier. In Cosmos DB, this will look like, let's go to do live. This will look like this. Data Explorer, let's have a look here. Items, and we have our first item here. Now, 5 minutes-ish left. I have two methods to make normally. I would create, in theory, and maybe I should just show you instead of doing it live. Let's do maybe that, just to make sure we get the full spectrum of what I wanted to share. So this is my demo that I made earlier before this session. And this is also the code you can find on my GitHub account. And what we've done here is our create to-dos, still the same as what we saw earlier. And I also created a get to-dos function. It's again HTTP triggered. This one is a get endpoint, so it is exactly the same endpoint. And here we have a Cosmos DB, and this is interesting, right? There's a couple ways of getting data out of Cosmos DB. In my case, I essentially, probably not the best idea. I get an enumeration of my to-dos, right? A reference pointer. And on line 25 here, I do a query on, okay, get me all the to-dos where my user value equals the user ID that I passed on the URL. You probably don't want to do this again in production. I just like this notation. I was playing around with it a little bit. There are alternatives. So again, if we go to the reference documentation here and we check the input bindings for Cosmos DB, you can do a trigger-based lookup based on the ID. And then you add your ID as part of your parameter set of your binding here, right? So you just add the ID. You can add a string or a query here, query.id. You can generate SQL queries where you pass in certain values that you might pass onto your query string. And the last one, I think that is the one I used, is where you can just get the entire set in a way and then parse in place with this type of code. So again, up to you which you want to use. We do describe, or the documents do describe when you should use which one, when you should use which one, and then use the one that is most suitable for your use case. So if there's to-dos for this user, I will get the to-dos. If there's nothing found, then there's no to-dos. So let me go back here to my create to-do. So let's paste again our first to-do in here. For myself, first to-do, note the user is Cedric. If I get to-dos on my demo here and I get to-dos for Cedric, I get the list of to-dos that is persisted in the Cosmos DB. I can see I tested quite a lot to make sure this works. Last one I wanted to show is publishing to-dos. And I think this is quite neat because what this does is it is triggered. It's a Cosmos DB trigger. And the cool thing here is this means you could just use Cosmos DB whenever something is added to your collection. You can trigger this function, or this function is triggered, and you don't have to add any event grids or anything else. You can do this directly. Every insert in the items collection will trigger this function. Very important part here is when you generate this code, right? When I add a new function, it will omit this part here, right? It will be generated without this. So it will just say, okay, my lease collection name is leases. Now you need to make sure you add, or often you will want to create your lease collection if it doesn't exist. If you don't add this one, it expects that there's already a collection, lease collection, right? So don't forget to add this one. Might save your you a bit of time. Another important thing to change here is by default, this is a void function, so it doesn't return anything. In our case, since we want to write to a to-do queue, to a storage queue, we want to write a string there. So make sure you change that here. And then the last one is you want to take that input, you want to verify that input that it's valid, and then take the first object and write toString this as your output, which will put this on the return queue. Now note that this is a bit weird here, that the storage queue is added above your function and not as part of the parameters. That's just the documentations that I'm following there. Not sure why this is a bit of a discrepancy between how you do Cosmos DB bindings and queue bindings, but that's in this case the way it is. So when we do this and we add files to our Cosmos DB, what you'll see, and let me go to my previous demo here, what you'll see is that the moment we trigger this function, right, I just triggered it with first to do, it will write to storage. And now I need to think, where did I probably put it here on my demo store. Let's have a look if I created a queue here. So you have my to-do queues, and you'll see that first to-do has arrived here. Now, if I trigger that function again, so I have my create to-dos here. I'm going to create my second to-do, follow Cloud Lunch and Learn on Twitter. So I trigger this again. I get a new ID, 025E. If I refresh this here, you'll see immediately 025E has been added. And this to show essentially that from here on out, you can start connecting things together. Something's inserted in your Cosmos DB, trigger a queue, or put something on a storage blob or whatever. Essentially, it's quite easy and quite fast, and you do that in, I mean, in this case, how many lines is it? 28 lines, and most of it is imports, right? So really efficient on how to do those imports. So wrapping up here, as I want to respect everyone's time here, I got, as in last session, I got some learning resources. First one is the same as last session. It's a create serverless application learning path on MS Learn. I will reach out to the Cloud Lunch and Learn team and make sure we post all the links in the description of this video. The second link here is a reference to the Microsoft Cloud Workshop. In that Cloud Workshop webpage, there's some very cool workshops, and one in particular, the serverless architecture, which walks you through step by step on how to integrate from functions with some of our cognitive services and some of our queuing services. Really cool workshop you can do by yourself, as long as you have an active Azure subscription, and do take into account to run through all of the serverless architecture Cloud Workshop. You will need about half a day, about 4 or 5 hours. I think you will probably need if you want to take your time and do it properly. Last one I want to share here is our Azure Samples repository on GitHub. Again, if you're looking for ideas or inspiration or just things that you want to deploy as an exercise for yourself, have a look there, search for functions, search for Kubernetes, for example, search for containers, and you'll find some really cool sample applications used throughout the documentation on the Azure Docs that you can then deploy yourself and play with. So definitely worth a look there. And with that, I think I have to wrap up this session for today. I want to thank everyone for attending. And next week, the Monday, 30th of November, we'll be doing something similar as today, looking into detail a bit more on logic apps and create a couple of logic apps and do some fun stuff there. And then the last session for now is on December 7th, where we will do again some hands-on coding with Azure container instances. So for everyone who's been enjoying this, do feel free to reach out and ping us on Twitter or here on YouTube. Let us know, give us some feedback, and we can definitely see if there's need for more sessions and more in detail sessions on specific topics within the serverless realm. So that's it for today. Thank you very much. I don't know, Lisa, is there anything you want to add to wrap up today?
So Darren just wanted to clarify where you were pulling the images from, but that's our only question. And I just want to remind everyone to register to the session if you haven't already, and get access to those learning materials.
Absolutely. So the images, I just took a bunch of images from Unsplash, which is a license-free image repository. Is great for wallpapers and so on. So every wallpaper comes with the photographer who made it that you could include, and that's part of the file name for saying thanks, let's say. But it's Unsplash, that's what it's called, and it's royalty-free images for your backgrounds. Really cool. There's some very cool plugins written on top of that for browsers that you could have some nice backgrounds in your browsers based from there.
Awesome. Thanks so much for sharing that. Well, thanks, Cedric. We will see you back again next Monday. Any questions, anyone, reach out to us and we will either answer them in the next session or get back to you.
Perfect. Thank you. Thank you, Lisa, and see you next week.
Ciao. Bye.